Now that we learned about the concept of a perpetuity, let's handle the simpler, in terms of its structure, uh, set of cash flows called annuities. And annuity is a perpetuity that has an end. So let's say with T is the number of payments in this cash flow system. And we assume that payments are made at the end of each period. There is something related called annuity due, where each payment is made at the beginning of the period. You can easily handle those. And annuity due is basically an initial payment plus an annuity that has one less period. But we're not going to deal with those, so you can ignore those. Now, let's kind of do a timeline. This is going to be helpful for us. This is now period 1, period 2, period T, T plus 1, and so on. And we know we're going to designate with $C as the periodic payments. So annuity has payments of $C every period until and including the last period. After that, you got zeros. But I also put that timeline for a purpose. So it's a perpetuity that has an end. The question is, how do we end up getting a tractable formula for the present value of that? We're going to kind of do divide and conquer. Let's do our timeline again. Let's call this T. And let's call this component from 0 to T, A, short for annuity. From T to end of time, B. And the whole thing, which is A plus B, of course. If I know the value of A, value of B, adding those values is going to give me the value of the whole thing. And I'm going to call this P for perpetuity. Now, we're going to have C dollars for periodic payment. And let's have R as our period interest rate. At this point, I'm not going to worry about using APR and stuff. I'm going to assume C is a periodic payment and R is a period interest rate. When we're calculating these in Excel, we're going to make sure that we are using the proper interest rate. For now, these are abstract periods. Could be a month, could be a year, could be a quarter, what have you. Now, we can calculate present value of P, right? Because that is a perpetuity. Well, we know how to do that. C dollars divided by R. That's good. So if I can figure out a formula for present value of the cash flows in B, then all I have to do is deduct that from present value of P. I'm home. But let's recognize what B is. If somebody told you that, let's say T is 10 years and $C is $10, you're going to wait 10 years, and starting year 11, I am going to give you $10 every single year until the end of time. So how much you would be willing to pay for that? Well, I need to calculate the present value of those and go from there. First, let's divide and conquer. Let's time travel to time period T. Standing here, looking into the future, B looks like a perpetuity, right? If that was your present, it is a perpetuity. Starting one period from now, you're going to start from T, of course. You're going to start getting $10 until the end of time. So as of present value of B as of T is C dollars divided by R. but that's t periods into the future. Well, I need to discount that to present. And we know how to do that. Then present value of b, technically for period 0, and I'm going to call that PVB anyway, that $C divided by R, the whole thing divided by 1 plus R raised to the power T, because that's how we discount a payment that is T periods into the future. Well, that means present value of P is present value of A plus present value of B. Thus, present value of A is present value of P. I am getting ahead of myself when I'm writing. Minus present value of B. Well, we have the formulas for both. The perpetuity that starts now is worth $C over R. The perpetuity that starts T periods from now is worth $C over R divided by 1 plus R raised to the power T. Collecting the terms, you get the formula for present value of an annuity. Present value of perpetuity adjusted by 1 minus 1 over 1 plus R raised to the power T. That's pretty much all it is. I know it is an ugly formula, and I just want you to know what it is, but you don't have to remember the formula. We will actually go ahead and use Excel functions to make these calculations. But I just wanted you to know where that formula came from and what it is in case you didn't have Excel with you and you had to calculate this. In the next video, I'm going to show you, using pretty much similar methods, how to calculate value of a growing annuity. A growing annuity is just like a regular annuity, except payments grow at a constant rate. You remember this from growing perpetuity. You can also think of a growing annuity as a growing perpetuity that actually ends.